Okay, good morning to all. Am I audible? Can anyone message? Good morning to all. Am I audible? Just mention in the chat box if my voice is audible. Yes, okay then. I will start the session. So today we will discuss personal safety measures. So in the personal safety measures, we'll discuss about the electric shock, safety, and earthing. So let us see what is meant by electric shock. First of all, so electric shock is the sudden discharge of electricity through anyone who touches the electrical equipment. So if we touch an electrical equipment, okay, and if current passes through our body, then that is known as electric shock. Okay. So when we touch any electrical good, if current passes through our body, for example, in this image you can see this person has inserted some screwdriver like thing, okay, into this socket. Immediately current passed through his body. That's why you can see how stiff he has become. Okay, so see here in this image, someone has inserted plug in the socket. Okay, and here insulation is broken. Okay, so black part that you can see is the insulation, and inside you can see the copper wires, this conducting material, it has come out. So if this forefinger touches those copper conductors when the plug is inserted in the socket, okay, this person will experience the current shock. What happens is current will flow through his body. So here in this image, if you see here, this is a conductor, okay, and this person, this human, he has touched this conducting material. Okay, so what happens, current will pass through this body. So in which path current flows through his body is shown here. This yellow color zigzag lines that you are able to see shows us that current is passing through the body. One second. So now, so this person, when current passes through his body, he will experience the electric shock. So the factors that affect the severity of this shock are how much magnitude of current is passing through the body. Okay, how much I, what is the magnitude? What is the I value? Okay, what is the current magnitude of the current that is passing through the body, and the path of the current through the body, in which path current is flowing. If you observe here current is passing through the path of the heart, through heart. Okay, so which is very dangerous. Okay, so in which path current flows through the body, that factor also decide how severe the shock, electric shock is. And one more factor that affects the severity of the shock is the time for which current is passing through the body. Okay, so whether the current has passed through his body for some fraction of seconds or for more than a second. Okay, it depends for how much interval of time current is passing through the body. Okay, one more factor that affects the severity of the shock is frequency of the current. So what is the frequency, okay, of the current? And one more factor, the last factor is physical and psychological condition of the person. Okay, so whether this person is physically fit or not, or whether mentally he is already he is in some stress condition, or what is this psychological condition. Okay, so all these factors will affect how severe the electric shock is. Now let us see the precautions against the electric shock. Okay, so what are all the precautions that are to be followed in order to avoid electric shock? So we don't want electric shock, isn't it? No one wants electric shock. So second, just a second, you just go through this image and meanwhile. You just go through this image and meanwhile. Okay, so you can see precautions against the electric shock. Okay, so first precaution is what we have to do is we should avoid water all times when working with the electricity. Okay, so here this person is trying to, he has plugged in the, okay, so he has plugged in this, what is it, hair dryer. Okay, and this person is trying to dry his or her hair with using this hair dryer. But if you observe here, the floor is wet. Okay, so on the wet floor this person is standing and trying to dry the hair, so which is not good. Okay, so we should avoid what, we should avoid water all times when working with what, electricity. Okay, so we should avoid water when working with electricity. That factor we must consider. So one more precaution against electric shock is a same precaution. This is also same example, of course. So see here, this in this image also, this person is trying to, what to say, what is this called, I forgot, cut the grass in his lawn. And okay, so while, and this machine that he is using to cut the grass in his lawn, it is electric. See here, this is a current wire, so which is plugged in. So if the grass is wet, okay, if the grass is wet, then it may be a dangerous task for him, so he may experience electric shock. Okay, so here, so the grass should be dry if we are using, what to say, if you want to cut the grass using an electrical lawn, means electrical machine to cut the grass in the lawn. Okay, so one more precaution is we should not touch the electrical outlets with wet hands. Okay, if your hands are wet, okay, you should not touch the electrical outlets with wet hands. So you can see here, this hand is wet and he is trying to plug in. Okay, so this person is trying to plug in even though that person's hand is wet. Okay, so water and electricity, they do not mix together, so we should never touch, we should not plug in any device if our hands are wet. Okay, if our hands are wet, we should not plug in any device. So am I audible? Is there any issue? Can anyone just mention in the chat box whether I'm audible or not? Is there an issue with the internet connection? Is my voice coming parallel to the images that I have been showing, or with the PPT that I have been showing? Am I audible? You can mention in the chat box if I'm whether I'm audible or not. Okay then. Next. Okay, okay. Okay, so let us see one more precaution that is to be followed to avoid electric shock. We should never use equipment with damaged insulation. Okay, So here you can see the insulation is damaged. This, okay. So if the insulation is damaged, we should not use that equipment with damaged insulation. Okay. One more second. I have. Okay, so whatever insulation that is provided to the conductor, it should be in proper and good condition. Then only we must use that electrical equipment. Okay, so next one is earthing. So earth connection should be maintained in proper condition. Okay, so if you observe here, I think this is some electrical equipment. I think this is an oven. So this is an oven and which is plugged in. Okay, so here this oven is not provided with any earthing. So if this person touches the oven, there are chances that current will flow through his body. Okay, if you observe carefully, these red dots, arrow marks, okay, flow through his body, and it will return back to the ground. Okay, if any fault occurs in that condition. Okay, if any under faulty condition. Okay, so if you see in this second image, okay, if you see in this second image, if you see the oven is properly earthed, therefore if there is any leakage of current, the current will flow through this oven in this path and it will go to the ground. Okay, so proper earthing should be provided. Otherwise, even in our houses, I myself also once experienced this. Once I touched the refrigerator, and immediately I felt the electric shock, and so when I tried to inquire, I came to know that my house was not, the earthing wire in my house was, uh, it was broken. So technicians came and they just reconnected the earthing wire, and later on that issue was resolved. And I later on when I touched the refrigerator, um, so I didn't feel any current passing through me. Okay, I didn't experience any electric shock. Okay, next. If we are using fuses and cables in our houses, okay, then those fuses and cables should be of proper rating. Okay, so here in this image also you can see this is the energy, what to say, electrical service board. Okay, it is available in all our houses. You can see in front of our houses, usually besides to the main door. Okay, so there will be electrical service board. So just below it, earthing is provided for every house. So every house will have earthing earthing connection. So it is also one of the topic that I will discuss today. So you can see this yellow color line is the earth wire, and this is our earth electrode. Okay, so every house is provided with proper earthing, not to avoid electric shock when we touch any electrical good in our houses. So you can see here, if earthing, person earthed via floor, so due to high voltage. So if earthing is not provided, what will happen when you touch an electrical good, current will pass through the human body. Okay, it will always, mostly it will try to pass through the heart and in order to reach to the ground. Okay. So we should use one more precaution to avoid electric shock is we must use rubber soled shoes while working. Okay, we must use rubber soled shoes while working. You can see here this person is working. He is on the transmission tower. You can see, so he is wearing rubber soled shoes. Okay, so while working with the electrical equipment, we should make sure that we are using rubber soled shoes. So you can see the image of this shoe also here. Okay, next. See, in this also you can see this, in these two images you can see no rubber shoes. So what has happened when this, it looks like a penguin, isn't it? It is looking like a penguin. So when this penguin touches this conductor, this is the conductor, this orange color line is the conductor. So when this penguin touches the conductor, what happens? Current passes through his body to the ground. Okay, so here in the second image, this penguin is wearing shoes here. Okay, this penguin is wearing shoes. So when this penguin touches the conductor, okay, so current is not flowing through his body, isn't it? You just carefully observe these two images. In one image, rubber shoes are not there. Okay, no rubber shoes. In the second image, rubber shoes are there. Okay, so when this penguin touches the conducting material, the conductor, what is happening? The current which was flowing through the conductor, instead of flowing through the conductor, it starts to flow through this penguin and it will reach the ground. Whereas if the penguin is wearing the shoes, okay, it will this precaution belongs to us also. We should follow that. Okay, so it's just a cartoonistic image. That's it, nothing else. Okay, so usually the earth what to say, earth resistance is measured by a device which is known as Megger. Okay, so always Megger test should be done to check the insulation. Okay, Megger test should be done to check the insulation of the electrical equipments. We should never touch two different terminals at the same time. Okay, if I think one more image is there. Yeah, this is Megger. Okay, so here insulation test is done. Okay, using Megger, insulation test of the conducting material is done so that we will come to know how much resistance is there and whether it will that conducting material cause the electric shock or not. Okay, so if there is a battery, you can see here this is a car battery I'm showing you. These two are the terminals of the car battery. So we should never touch the two terminals of the um, car battery at the same time. Okay, not only car battery, any battery. Okay, if there are two terminals, we should never touch those two terminals. This terminal and this terminal, we should never touch with our hands these two terminals at the same time. Otherwise, current will pass through our body. Okay, so now one more precaution that is to be followed to avoid electric shock is we should never remove the plug by pulling the wire. See here, this person is holding the wire. We should always uh, hold the plug while removing the plug or while inserting the plug. Okay, while removing or inserting the plug, we should always hold the plug. Okay, I forgot about the Google form. Okay, I'll create a small Google form with only one question and I will upload it so that at the end of the session you can give the attendance. Okay, so we should never pull the plug by simply holding the wire. Okay, so this image what is shown here is this should not be done. And here also if you observe here, this person is trying to use the vacuum cleaner and there is a plug here, and what he's trying to do is he is holding the wire and he's trying to pull the wire so that he want to disconnect the plug, and he's simply holding the wire and he's trying to pull it. Instead of that, what he should do is he should hold the plug and he should remove it. Okay, and the sockets that are placed in our houses, they should be placed at certain height. Okay, so if you see here on the right side image, approximately 400 mm height the socket is placed. So it should not be placed at the ground level. Sockets in our houses, of course you might have observed in your houses, the sockets will never be at the ground level. So sockets should never be placed at the floor level. They should be at certain height. At least minimum height of 400 mm should be maintained. Next, we should switch off the supply and remove the fuses before starting the work. Okay, so if I want, suppose here this person wants to this is just a small example, that's it. He wants to just fix the bulb inside this. Okay, so what he should do is he should turn off the switch. The switch is turned off. Okay, it is off. I am unable to write. The switch should be turned off. Okay, switches should be turned off before doing any electrical work. If fuses are there, those fuses should also be removed. Okay, so after turning on the switch, you should not do any electrical work. Okay, so we should always use insulated screwdrivers and line testers while performing any electrical operation. First of all, we must check whether it's current. Even after switching off the even after turning off the switch, we must with the help of the tester, this is a tester, with the help of the tester we must check whether current is passing through the electrical good or not. Okay, then only if after making after getting assurance that current is not passing through the electrical good, we must go for repair work or anything else, whatever we want to do we can do. Okay, so these are all the precautions that are to be followed to avoid electric shock. Okay, now let us see what is meant by earthing. So earthing is connection of the body of electrical equipment to the general mass of the earth, to the earth, okay, by a wire of negligible resistance. Okay, so simply connecting the electrical equipment with a wire to the ground is known as earthing. For example, if you see, this is a transmission tower. Okay, this is the transmission tower. It is provided earthing. Okay, so this is an earth electrode. Okay, so this transmission tower is earthed. So it is connected to an earth electrode to provide earthing. Okay, so one more image if you see here. So here whenever we have what to say in our houses, all the wires they will have three what to say, each wire will have three inside it. Each insulating part of the wire will have three wires inside. Those wires are, one is line, one is neutral, another one is earth wire. Okay, so definitely earth wire will be there. So this same image as I have shown you earlier, here this electrical good in the right side image, it is earthed. That's why if there is any fault or any leakage of current, current will not flow through the human body even if that human touches that electrical good. If it is not properly earthed, if the electrical goods are not properly earthed, then current, instead of flowing through the um, electrical equipment, okay, current will try to pass through the human body. Okay, so current always try to complete its paths. That's the problem with the current. So here also you can see, where is my cursor? Yeah, you can see in this image, this person, some cartoonistic image. This person is trying to touch some electrical equipment here, and since it is properly earthed, nothing will happen to him. Whereas this electrical equipment in this second image, it is not earthed. So this person will experience the electric shock. Okay, so there is one more image. So here this is a washing machine. Okay, this is a washing machine. So you can see line, neutral and earth connection. Okay, so this is our main supply, line and neutral. So here earth connection is provided to this motor inside this washing machine. So if any fault occurs, if current is flowing through this device, then that current will return back to the earth. So it will not pass through the human. So this is it, as I've already shown you the same image. So in our houses, proper earthing is provided. Okay, so exactly below the energy meter. In our houses, at the door entrance, you can see the energy board. So electricity service board. Below that, there will be earthing provided in order to avoid the electric shock in our houses. So I have one more image of some motor. So this is a motor. So see here. So these are the supply on off switches, red and green switches. And this motor is provided with earthing with the help of these earth electrodes. Okay. So you can see the in the next image. I can show you earthing. This is earthing. This is known as a pit. Inside the pit, you can see the earthing provided. Okay. So, so let us discuss few points about this earthing. So connection of this electrical equipment to the earth, as I already told you, is known as through a thin wire is known as earthing. Okay, and this wire will have negligible resistance. That this thin wire you can see here, earth wire. This earth wire will have negligible resistance. Resistance will be very low, very low. It brings the body of the equipment to the zero potential during electric shock. Okay, if we touch it, if we touch electrical goods in our houses, of even then proper earthing is provided. Then this it will bring the electrical equipment to zero potential. So we will not experience any shock. So earthing is a process in which leakage of current is made to flow to the earth to prevent the accumulation of excess current in the electrical devices that we are using in the houses. Okay, so that's why they will avoid the damage. Okay, that you see, even if there is any fault, even if there is any fault that has occurred in the electrical equipment, even if we won't touch, okay, so if that fault persists for a longer period of time, that fault will cause excess current to flow through the device, and the device may get damaged. So every electrical good, it has to be provided with proper earthing. Of course, not every electrical good. Simply in our house, proper earthing for the house, if earthing is provided, as shown in this image, that is more than sufficient. So that all the electrical goods on all the electrical goods, even if fault occurs, that fault current will go flow into the earth. Okay, and excess current will be reduced if fault occurs in the electrical equipments. Now, let us see the necessity of earthing. Okay, what is the need to provide earthing? So here also in this image you can see main purpose here is one of the main purposes to protect the human being from danger of shock in case they come in contact with the charged frame due to some defection in the insulation, or if insulation breakdown occurs. Okay, so if insulation breakdown has occurred, okay, so you can see in this image here insulation failure has occurred. Insulation fails. Here it is written here. If insulation failure occurs and accidentally, if I not accidentally or accidentally or intentionally, if we touch that electrical equipment in which insulation failure has occurred, then we will experience the shock. Okay, if this equipment is provided with proper earthing, you can see earthing provided here. If this equipment is provided proper earthing, even if insulation failure occurs, okay, even if insulation failure occurs, then current will not pass through our human body. Okay, so you can see in the first image you can see current flows through the body without earthing, and current flows through the ground with earthing. Okay, the person gets protected against electric shocks due to earthing. Okay, so the above image, this image is without earthing and this is with earthing. Whenever insulation breakdown occurs, if insulation failure occurs, if okay, so now that is one of the reason for providing the um, earthing. Okay, what is the need of earthing? That's what we are discussing, necessity of earthing. So here also you can see this person uh, is touching this some washing machine. Okay, and current is passing through this body. Okay, So after providing proper earthing, here earthing is it shown here. Okay, after providing proper earthing, even if this person touches this, okay, here you can see ungrounded, here it is grounded. So grounded means earthing. So after providing earthing, so even if this person touches the washing machine, that person will not experience any electric shock. Okay, so now if thunder occurs, okay, if thunder occurs, then what will happen is during rainy season, whenever thunder occurs, what will happen is there will be high discharge of electrons from the clouds. This is discharge of electrons. This is nothing but discharge of electrons from the clouds towards the tallest objects. So you can see here, lightning has reached the tallest object here. Okay, towards the tallest object. If no tallest object is available, then it will directly strike the earth. This thunder will strike the earth. Okay. So, if earthing is provided, then it guarantees the safety of the electrical appliances as well as devices from excess amount of electric current. If earthing is provided, okay. So, if this discharge occurs due to this lightning, okay. So this discharge is known as voltage surge or lightning discharge. Okay, if it occurs, then if all the electrical equipments are provided with proper earthing, then they will protect the appliances or the electrical equipments from this high voltage surges and lightning discharges. Why? Because approximately around 1000 volts of electrical energy is discharged from the clouds. Okay, approximately around this is 1000. Okay, around 1000 volts of electrical energy discharged from the clouds towards the tallest object. You can see this hilly area here. The discharge has struck this area and discharge has struck these tall buildings and so on. Okay, so these discharges will definitely, if they are flowing through the electrical equipment in our houses, then um, it will cause excess current in those electrical equipments and those electrical equipments will get damaged. Okay, and if in that moment if we touch those electrical equipment, instead of flowing through that electrical equipment, the current will flow through our body. Okay, and we will experience the electric shock. Okay, so what this earthing is doing, it is providing an alternative path for the leakage of current, hence protecting the electrical equipment. So it is allowing the what to say, the electrical current to flow to the ground, okay, by some other path. So usually in order to protect against lightning, usually surge absorbers or lightning uh, arresters are provided on the top of the tall buildings. Okay, on the top of the tall buildings. So these three images, one, two, this one, two, and three, they are the surge absorbers or lightning arresters. So what these lightning arresters, usually they are placed at the top of the tall building. So what these will do is they will absorb the lightning discharge that is coming from the clouds, okay, and they will send it to the ground. So you can see the path of this discharge flowing towards the ground. Okay, so because ground is here, earthing is provided at the bottom of this tall building. Okay, so here one more image. So this is lightning current. This is thunder, lightning during thunder. Okay, so this is flowing to the ground. Okay, so here earthing bar, cutoff bar, earth measurement bar is provided. You can see this circle. Inside this circle is provided now to provide protection against lightning to this house. Okay, so lightning protection, one more image you can see here. uh, this looks like a TV antenna, but here actually here it is a surge absorber. Okay, it is a surge absorber, that is the surge means voltage surge that is coming from the clouds. Okay, so this will flow through this to the ground through this path. So you can observe those blue arrow marks. You can observe this blue arrow marks. My cursor is very sensitive. Okay, and here earthing is provided to this house. So if earthing is not provided, see here. So when lightning strikes, okay, then what is happening? If we are standing outside the house, okay, so if you are standing here outside the house, even if we are inside the house, we will experience the electric shock. The lightning discharge will try to pass through our body towards the ground. So here, even though lightning has occurred in the first image, in this image, even though lightning has occurred, this person is able to stand here without any, what to say, without any hesitation or any fear. Okay, but this person, you can say, is this person has experienced the electric shock. Okay, so let us discuss types of earthing. There are two types of earthing: plate earthing and pipe earthing. So let us discuss plate earthing and pipe earthing. So I can show you some images. Let us start with plate earthing. You can see a plate here. It looks like a plate, isn't it? It looks like a plate. So this is plate earthing. So in this method, a copper, if you observe carefully, this material, it is copper material, isn't it? I hope you know how the copper material looks like. So in this method of earthing, a copper plate or galvanized iron plate, okay, galvanized iron plate or copper plate of some dimensions are, I will show you somewhere, it is there, yeah. So copper, this is the copper plate, this is the copper plate which I have shown you in the earlier image. This image, in this image you can see the copper plate, isn't it? So this copper plate dimensions I am showing you in the next image. Dimensions are 60 centimeter, 60 centimeter into 3.18 mm copper plate. Okay, so length, breadth and thickness. Okay, length, breadth and thickness is given. So it is 60 centimeter into 60 centimeter, 3.18 centimeter is placed vertically down inside the ground at a depth of 3 meters. Okay, so this is the ground. This is the ground. This is the surface of the earth. This is the surface of the earth. Okay, so this is the surface of the earth. This is the surface of the earth. I think I should draw lines like this. I hope you know, whenever we draw the earth, we draw lines like this. So below the surface of the earth at a depth of 3 meters, the copper plate is placed. Okay, I think I have few more images. Yeah. So this plate is surrounded by alternate layers of salt and coal. So if you observe, this is the plate in this image. This is the plate. Okay, at a depth of how much from the surface? It is at a depth of 3 meters and it is surrounded by alternate layers of coal and salt. Okay, so you can see this is coal layer, next salt, next coal, next salt. Okay, at the bottom there is sand. Okay, at the bottom it is sand. So this plate is surrounded by alternate layers of salt and coal with a minimum thickness of 15 centimeter. Thickness of the salt and coal will be around 15 centimeter, that you can see in the previous image. So thickness of the salt and coal is around 15 centimeter. It will be around 15 centimeter. So what is this? This portion, this is the salt and coal which is surrounding this plate. Okay. So the earthware drawn from the galvanized iron plate are bolted to this to the galvanized pipe. Okay, so pipe means this is here there will be a pipe. Let us assume this is the pipe and this is the plate. So this is also made up of GI material, galvanized iron material. So both are bolted together. Here you can see. So they are bolted here. So let me see, is there any other image? Bolting image is not. So yeah, you can see this is bolted. They are bolted. Pipe, galvanized pipe, okay, and this plate are bolted together, okay, and this GI pipe. This is the pipe. This is the pipe, GI pipe, galvanized iron pipe. It is fitted to a tunnel or funnel. We can say. You can see here funnel at the top. This is the funnel. Okay. So, which is made with concrete cement. Funnel is made with concrete cement. So, it is fitted with the funnel on the top in order to have a effective earthing by pouring salt water periodically. So, in order to have effective earthing, what is done is in the funnel, okay, uh, okay, so actually this is known as pit, okay, PIT pit. Concrete cement structure what is shown here is known as pit, and here this pipe is broadened here, so this opening you can call it as a funnel. So through this funnel what will happen, okay, actually in this pit I think I have an image of pit. This is pit. Okay, so in this pit continuously salt water is poured to not increase the effectiveness of earthing. Okay, so the earthing efficiency will increase with the increase of the plate area and depth of the pit. Okay, what depending on how much depth the pit is and depending on the dimensions of the plate, the effectiveness of the or the efficiency of the earthing will increase. Okay, and how depth the pit should be. This is known as pit. This you can see. Okay, you can see these sort of pits even in your outside your house. You can see if it is visible. Okay, so yeah, because I have not seen this pit in my house. Okay, because I was told that they have placed a small a temporary enclosure is provided. So here also you can see this is some temporary enclosure. So which is slightly visible here, but temporary enclosure is provided. If we want, we can open it, and if we want to make any, I means if we want to change the plate or whatever, we can do it. So that's why in outside my house, um, I can't see any pit, but usually pits are provided outside the houses just below the energy meter. Okay, and this depth of this pit will usually depends upon the resistivity of the soil. The only disadvantage of this method is that discontinuity of the earth wire from the earthing plate, which is placed below the ground, as it cannot be observed physically. Okay, because since the ground wire is not cannot be observed physically, so it may cause misleading and result into heavy loss under fault condition because the earthward is not visible. Therefore, if faults occur, then we may not be able to predict that. Okay, so this is about the plate thing. Let us discuss the next type of earthing, that is pipe earthing. So here also we are going to use the same material, that is galvanized iron pipe of 38 mm diameter and a length of 2 meters with 12 mm hole in is placed vertically in the into the ground at a depth of 4.75 meters. So here you can see this pipe. Okay, so somewhere, yeah, so this is it. The diameter of this pipe will be around 38 mm. Let me see here, 38 mm is mentioned or not, I didn't notice that. Yeah, here you can see 38 mm galvanized iron pipe Okay, whose this is galvanized iron pipe of 38 mm diameter and length of 2 meters. Its length is here, it is mentioned some 2.5 meters. It's okay. Okay, it's approximately 2 meters length. Okay, and with the 12 mm holes is placed vertical into the ground. You can see some holes here. Okay, you can see some holes, so which are around 12 mm. Okay, and it is at a depth of 4.75 meters depth inside the ground. 4.75, is it uh, yeah, hole, see, I told you holes will be of 12 mm diameter, and it is at a depth of 4.75. 4.75, I don't have any image which is mentioning 4.75 depth. That usually the depth you can see in this image, it is around 1.5 meter depth, and another image is there of around 2.75 meter depth. Okay, but usually it will be around 4.75 meter depth. This is placed. Okay, so this is a pipe which acts as earthing electrode. So just now I have told you that the depth of the pipe will be around 4.75, but I have shown you two images. One is of depth 2.75. Another image I am showing you here. Another one is of depth 1.5 meters. So this depth varies. So the depth of the electrode at which the electrode has to be placed. Okay, the depth at which the electrode has to be placed will depend upon the condition of the soil. So depending on the condition of the soil, the depth may vary. The depth will not be same. So the pit area means this one. This is the pit area, which is pit is made up of concrete cement, and here this is a pipe, galvanized pipe, which is connecting the earth electrode with the concrete part, that is pit. So the length of this pipe will be around 19 mm. Okay, the length of this pipe is 19 mm. This is our funnel, and this is the concrete. Okay, so the concrete is continuously filled with what? As I have told you earlier, it is continuously filled with salt water to, in order to increase the efficiency. Okay, so the earthing wires are connected to the top section of the pipe here. Okay, so earthing wires, not like previous case, but here in this case, the earthing wires are connected at the top section of the pipe above the ground level with nuts and bolts. So the contact surface of this GI pipe with the soil is more when compared to the plate type. Okay, the contact surface of this GI pipe with the soil will be more. Hence, it can handle large leakage currents for the same electrode size. Okay, so the earthwire connected to this GI pipe above the ground level can be physically inspected time to time. Whereas in the previous case, this is the earthwire. You can see here, this is earthware, which is physically visible in the case of pipe earthing, whereas in the case of plate earthing, this earthware is not physically visible. That was the drawback for that. Here, this is an advantage, so it can be examined physically in order to check whether it is properly working or not. The only disadvantage of this pipe earthing is that pipe length has to be increased sufficiently in case of soil of high specific resistance. If the specific resistance of the soil is high, then the length of the pipe is to be increased. Okay, that's it for today. That's it. Um, Today's session is over. I'll just take the attendance. Okay, I forgot about the sorry, I forgot about this. No, this is plater. Yeah, pipe earthing. Yes, I forgot about the uh, layers of the salt and charcoal which is provided around the pipe. Okay, GI pipe. So this is our GI pipe. So these are the layers of charcoal. So you can say at the bottom layer charcoal, then salt, next charcoal, next salt. Similar to your plate earthing, here also the layers of salt and charcoal are provided around this pipe. Okay. So here earth leads are brought out of the above the ground level. That is the advantage of this pipe earthing when compared to the plate earthing. That's it. I will just create a Google form and I will take the attendance. If you have any issue with the attendance, opening this Google form, inform me. Current will not, someone has mentioned here, why will the current flow through our body when we wear a rubber shoes? Current will not flow through our body when we wear a rubber shoes. If we are not wearing, current will flow. That's what I have told you. Okay, I'll show you the image. When we are wearing rubber shoes, current will not flow through our body. How can current will flow? Rubber is an insulator. It is a bad conductor of electricity. So just carefully observe this image. Just carefully observe this image. Here in this in the first image, current here rubber shoes are not there. No rubber shoes. So you just observe the red color line, zigzag line. That red color line is nothing but current. It is current. Okay. So here after wearing rubber shoes, which is bad conductor of electricity, the current flows through the conductor, not through our body. That's what I told you. If we wear rubber shoes, since rubber is bad conductor of electricity, current cannot pass through our body. It will not flow through our body. We should wear rubber shoes whenever we are using electrical energy. So here in this image, use the rubber soled shoes while working with electricity. So here in this image, this person is wearing the rubber shoes. That's why current will not pass through his body because rubber is an insulating material. Link is not working. I'm able to open it. Okay, I will try. Wait. Is it working? Check. Once again, check. Is it not working? If it's not working, inform. Okay, someone has messaged completed. So if you after just providing the attendance, you can mention in the chat box that you have completed, so that I will come to know that you are able to give the attendance. I can even check the responses actually. I think so. Am I able to check the responses? I think I can check. I will just check. Is this today's form? Is this link not working? Is the link not working? Okay then, okay. So just give the attendance and leave the session. Okay. So if you complete, just type C and leave the session, all of you. I have received more responses than the people who have attended. Okay. So shall I close the session if attendance is over? So it seems there are no concurrent viewers. Till now 49 responses. Okay, I'm closing the session. I hope no one is left over. Responses are more, but people who have attended are less. Okay, I'm concluding.